Chapter 3. Loop Quantum Gravity and Its Connection to Temporal-Subjection Theory. What if reality isn't fixed? What if, like space-time in LQG, it's a collection of quantum possibilities waiting for consciousness to choose? Time might be quantized, but the experience of it is continuous. That's the magic of consciousness. It takes the discrete and makes it seamless. Clovis. Loop quantum gravity, LQG, is one of the leading theories attempting to unify general relativity, which describes the gravitational force, with quantum mechanics, which explains the behavior of particles at the smallest scales. Unlike string theory, which posits extra dimensions and fundamental strings, LQG approaches the problem by quantizing spacetime itself, proposing that space and time are made up of discrete, indivisible units. Core concepts of loop quantum gravity: discrete nature of spacetime. Quantization of space. In LQG, space is not continuous, but is composed of tiny, finite loops, known as spin networks. These loops are the fundamental building blocks of space, representing the smallest measurable units of area and volume, according to quantum geometry, quantization of time. Similarly, time in LQG is also discrete, advancing in quantum ticks rather than flowing smoothly. These discrete intervals of time are tied to the evolution of spin networks, leading to the concept of spin foams that represent the history of spin networks over time. Background independence. No predefined spacetime. One of the key features of LQG is that it does not rely on a fixed spacetime background. Instead, spacetime itself emerges from the interactions of spin networks and spin foams, making LQG a background-independent theory. Absence of a smooth continuum. Planck scale. Granularity. LQG predicts that at the Planck scale, approximately 10 to the negative 35th meters, spacetime is fundamentally granular. This contrasts with the smooth continuum assumed in classical physics and general relativity, suggesting that the fabric of the universe is woven from these quantum loops. Linking LQG to temporal-subjection theory, TST. Quantized time and temporal dimensions, LQG's discrete time and TST's temporal dimensions. LQG's concept of quantized time aligns with TST's idea of multiple temporal dimensions. In TST, consciousness may navigate through different potential futures, or temporal dimensions, which could correspond to the discrete ticks of time in LQG. Each quantized unit of time in LQG could be seen as a point at which consciousness can shift, or align with different potential timelines. Navigating spin foams. In LQG, spin foams represent the evolution of space over time. Within TST, consciousness could interact with or influence these spin foams, guiding the evolution of space-time toward a specific temporal dimension or potential future. Background independence and subjective reality. Subjectivity in TST and LQG. The background independence of LQG, where space-time is not predefined but emerges from quantum interactions, resonates with TST's idea that reality is subjective and influenced by consciousness. Just as spacetime in LQG is not fixed but dynamic, TST proposes that our perception of time and reality is shaped by individual consciousness, which can potentially influence the unfolding of different temporal dimensions. Emergent spacetime and subjective experience. TST suggests that what we perceive as linear time is a filtered experience of a multidimensional reality. LQG's emergent spacetime concept supports this, proposing that our experience of time is an emergent property of deeper quantum-level interactions. In this view, consciousness might play a role in selecting or shaping the emergent properties of spacetime, aligning with specific potential futures. Granularity of spacetime and conscious experience. Granular time and consciousness. The granularity of time in LQG, where time advances in discrete steps, could provide a framework for understanding how consciousness experiences different temporal dimensions. TST posits that consciousness can shift between potential futures, and LQG's discrete time intervals might represent the moments where these shifts can occur. Each tick of time in LQG could correspond to a decision point where consciousness influences which timeline unfolds. Quantum loops and temporal shifts. The loops that make up space in LQG could be linked to the pathways through which consciousness navigates time. In TST, the practice of focused intention or altered states could allow consciousness to loop through different temporal dimensions, aligning with the quantum structure of spacetime proposed by LQG. In TST, the idea of discrete time in LQG aligns well with the theory's notion of subjective time. Consciousness filters and navigates these discrete units of time, giving us the impression of a smooth, continuous flow, even though time is made up of quantized ticks. The interaction between consciousness and these discrete moments could explain why time feels fluid to us, and how we might experience different potential futures, or temporal time dimensions, TTDs. Loop quantum gravity provides a robust theoretical foundation that can complement and enrich temporal-subjection theory. By linking the discrete, granular nature of spacetime in LQG with the idea of consciousness navigating multiple temporal dimensions in TST, a novel perspective emerges, one where reality is not a fixed backdrop, but a dynamic interplay between quantum processes and conscious experience. This integration not only deepens our understanding of both theories, but also opens up new avenues for exploring the nature of time, consciousness, and reality itself. Consciousness doesn't just experience time. It molds it, dances with it, and reshapes it with every thought and decision. The flow of time is an illusion, crafted by consciousness, navigating through discrete moments like pages in a flipbook. Clovis.